So this booklet is a lot of maths, numeracy style questions that you will come across, especially in year 10 towards the end of the papers, and then they come up again in year 11. So first off, I put a knowledge organiser. Like before, you can pause, kind of use it as and when you need it, but there's different all the different chemical calculations that you might be at. Like all of the other ones, you've got that glossary, kind of keywords. There's a little bit less than normal because obviously a numeracy style topic doesn't have as many key words. As before, the core knowledge questions kind of get more difficult. The reason I've put these two here is because they're likely to be the two that you won't be given. Now, there are other ways to work out reacting mass, but the way that we would have taught you was that way. What's a reactant? And then moving down, so you've got MR, or relative formula mass, they might say. Formula mass. Then percentage, ignore that little 2 there. That's a mistake. I hopefully have deleted it in your booklet. Then moles. Now, a big way that I remember moles is I do use the triangle, and I remember a mass standing over poor Mr. mole, and then remember it's times there and then divide, and then I just cover whatever, but I know that that equation is written out like that. Sometimes you get given it just depends. Empirical formula, then you always do divide by the smallest, is mostly the most common thing to think of here, and then this is the reactive mass question. Percentage yields is quite a nice question, just remember to times by 100, but with all of them you can pause and have a little look. I've also included some more practice questions. I'm not going to go through them in the same way that I will the past paper questions, but again, please have a go at these, and if there's any you want me to go through, then just drop me an email. So first kind of question, because it does come up quite a lot, is, and this is how they tend to link all the maths together, is by using like flame test colours and silver nitrate colours. So you need to know your flame test colours, and then you need to know your silver nitrate. So the first one, barium, gives you the apple green, bromide's the green precipitate, lithium's a red flame, chloride's white, sodium's yellow, iodine is a yellow precipitate. Sometimes they'll do it in reverse order. They'll give you the compounds and expect you to name them. This is a kind of a higher order question. Sometimes these go up to 3 marks, but they did give you the kind of words that they would expect you to use. So you would have done top, swap, drop. Be careful of that one. That's an unusual one there. So magnesium is 2 plus, nitrate is 3 minus, 1 minus, sorry. Keep that 3 constant, don't move it. So top, magnesium 2, NO3, 1, magnesium 1, if we swap them, NO2 up there, keep it, and then drop them. When you're dropping them, you can keep the 1, but because there's 2 elements in that ion, put the 2 outside the bracket. If in doubt, put 2s, which is kind of what that one works out to be there. Calculate the number of moles in the mass, give your answer in standard form. So straight away, I've seen the word moles, so I'm thinking of my equation, mass standing over Mr. Mole. That's what I'm going to do first. It tells me to give the number of moles. I know my mass is 0.103. Nice, easy. Got to work out the MR. I know how to do that. I've done a little example there. So there's your answer, and then to put it into standard form. Okay, remember standard form is where it's a whole number with a times 10 at the end. Next one then is looking at atom economy. So atom economy is the product over total reactants. You are just again using the MR. Okay, you are using the MR. You include the numbers in front. So that's why I've written there 17 times by 2 would give you 34. Plus another 34, so the MR of the total reactants is 38 over that times by 100. This is a bit of an unfair question. I think this would be a little bit maybe gone over for GCSE, but you can see here how you don't have to include numbers in all of them, so I think that's a bit of an unfair question. Another now you can see how I've written the total for the reactants over the desired product times by 100. Simplest formula is the same as empirical formula, so if they ask you to do simplest or empirical, please just be careful of that. The other thing is sometimes they'll give you, instead of grams, they'll give it to you in percentage. It's the same thing. So I've got my mass over my MR, and they've given you the MRs there, and then I've divided by the smallest. Okay, whenever you get 1.5, you need to double it. So that means I had to double that side as well. 1.5 is the only one you'll come across at GCSE. Exactly the same here. So this is something that they sometimes do as well. So 25.4, they haven't actually told you how much chloride that you've got. They've just told you the ion, but they've told you've made iron chloride, so it's only 2 things. That's why I've done that little taking away there. Same process then. They've given you the MRs, divide by them, divide by the smallest. Again, a little question. So again, same kind of thing. There was an oxide, 4.6 of it was sodium, so do a takeaway. And then again, they use this word simplest formula a lot, but empirical formula is the kind of correct word, but same thing. Mass over MR, divide by the smallest. Looking at this question, then it's a reacting mass question. The reason I know it's a reacting mass question is because it says maximum mass here. So the reacting mass question is known mass over known MR times by unknown MR. So the mass I know is 1.5 grams of carbon, okay? They want me to work out the maximum mass of copper, so I get rid of them too because I don't need them, okay? The MR of carbon is 12, then copper is 64, but there are 2 of them. I put it all into the equation and it works out as 16. Now this type of question comes up quite a lot. You only made 12 tons, but you should have made 16. So you have to work out percentage. If you don't get an answer here, just put a random number in to make sure that you can get the mark for the second bit of the question there. Again, the greatest mass, that's how I know it's reacting mass. I can use that equation from up here. As you can see, cross that one out, I don't need it. I've worked out the MRs, which is mostly the hardest bit. You know how to do that. They gave me a mass of magnesium chloride, so 4.75, divide by 95 times by the 58. So very similar question that you will be